Let's look at the common learning trap. Why students think they know something before they have really learned it. Our brains are optimized for rapid response and survival, not effective learning. That's what they so easily use mental shortcuts. One of the phenomena that must influence us is the fluency heuristic. When material is presented clearly, logically, and charismatic, the brain interprets ease of processing as a signal. I understand this. The problem is that fluency isn't the same as lasting understanding. This creates an illusion of competence, a situation in which students confuse knowledge of a text, slide, or lecture with true mastery of the topic. This illusion is often shattered only when the student has to apply the knowledge in practice or explain it in their words. This is when the illusion of depth of explanation becomes apparent. The student feels like they know what's going on, but when they begin to explain the phenomenon step by step, it turns out they've retained a general outline rather than a deep knowledge structure. This idea is linked to the Dunning-Kruger effect. Early in their learning, novices sometimes overestimate their competences because they don't yet have enough knowledge to recognize their shortcomings. They lack an internal cognitive map that would allow them to access what they don't yet understand. On the other hand, more competent individuals can fall into a different trap. Instead of appreciating their real skills, they attribute success to luck or an easy task. Combined with information bias, this can reinforce imposter syndrome. This occurs when we notice information that confirms our doubts and ignore evidence of our competence. As lecturers, we are also not immune to cognitive traps. One of the most serious is the curse of knowledge. When we become experts, our knowledge seems obvious and intuitive. We lose sight of the initial steps that the beginner students stumble upon. We can also unconsciously succumb to the anchoring effect, which means judging students' progress based on first impression or first response. So, how can we design classes that help overcome these illusions? First, combat the illusion of fluency through active replay. After a short fragment of material, ask students to write down 3 key points, draw a simple diagram, or explain a key concept in their words without referring to their notes. Second, ask students to explain difficult terms in simple but precise language. This indicates that they understand the topic more deeply than just recollecting a definition. Third, divide longer classes into shorter blocks. This reduces the primacy and recency effect, which is the tendency to memorize easier the beginning and end of the material. Fourth, use checklists and clear quality criteria. This provides students with a more objective point of reference and help reduce confirmation bias. Fifth, let's introduce short anonymous diagnostic quizzes. They will help safely check what the group truly understands and what only seems familiar. Awareness of all those cognitive traps will help design better and safer learning environments.